Hi, welcome to this Blender video tutorial entitled Bezier Curves and Circles Handles. Although Blender is primarily a mesh modeling application, it does contain some curve modeling tools. One of Blender's basic curve modeling tools is the Bezier curve. A Bezier curve is a parametric curve that's defined by a set of control points, each having a set of handles that control the shape of the curve moving into the control point and moving out of the control point. When a series of Bezier control points are connected, or extruded as they are in Blender, they form a uniform, non-rational B-spline. A closed Bezier B-spline is referred to in Blender as a Bezier circle. Bezier curves and circles have their own tool set, and can in many cases substitute quite nicely for many of the Blender mesh modeling tools. To demonstrate Blender's Bezier curve, I have a blank Blender scene to which I will add in top view a Bezier curve object. I'll zoom in a bit on the curve and tab into edit mode. The Bezier curve has two control points located on either end of the curve. These points are selectable and can be translated much like vertices in a mesh object. Each control point has a set of handles that controls the curve going into and out of the control points. The steepness of a curve can be controlled by moving the handle closer to or farther away from the control point. The curve itself, in edit mode, has a series of arrows that indicate the direction of the curve. A Bezier curve has a logical front end and a back end. The arrows point towards the curve's front end and away from the curve's back end. I'll click on the Object Data button in the Properties panel. This displays all of the Bezier curve property controls. By default, the Bezier curve is a 3D curve. That is, its control points can be moved along the z-axis. I'll switch to front view. Here the z-axis is running top to bottom. I can select one of the end control points of the Bezier curve and move it in the z direction. I'll rotate my view so that you can see this better. I'll press Ctrl Z and undo this movement along the z-axis. The control points can be constrained to the XY axis by clicking on the 2D control button. Now I am unable to move a control point in the Z direction. I'll go back to top view. Note that when the curve is constrained to the XY plane, the arrow markings are no longer displayed. There are 4 different types of Bezier curve handles. When you first create a Bezier curve, the handles are in align mode. That is, the handles always form a straight line. Moving one handle on a control point will cause the opposite handle to move in kind. When not selected, align handles are colored purple. If I select a control point, which selects the handles as well, and press the H key, the handles will turn black in color, and they are now free mode handles. Free handles can move independent of their opposite handle. I'll select this bottom handle and move it. As you can see, this handle controls the curve going into the control point. I'll select the other handle. As you can see, this handle has no effect on the curve because this handle controls the curve leaving the control point. And as there is no curve leaving the control point, its position has no effect. I'll select the control point and hold down my Control key and left-click, creating a new control point. Now I'll go back to that handle and move it. As you can see, it now controls the curve leaving the control point. Notice that the new control point has free handles. Whenever you create a new control point, it will take on the handle type from the previous control point. I'll select the last 2 control points by selecting one and holding my Shift key down while selecting the other. The H key toggles back and forth between align handles and free handles. I'll select all 3 control points. I'll now press the V key. This places the selected handles in vector mode. In vector mode, the inbound handle points to the preceding control point, and the outbound handle points to the succeeding control point, causing the curve to be a straight line between control points. I will deselect the control points. Notice the vector handles, when not selected, are colored green. I'll select one of the Bezier curve control point handles. Note that when I move the vector handle, it immediately turns into a black colored free handle. There is one more handle type called Auto. I'll select all of the control points and press Shift-H. Auto handles, which are colored yellow, are handles which Blender automatically sets to provide a smooth curve shape. When I select one of the handles and move it, it automatically turns into a purple-colored Align handle. I'll select the left end control point and hold my Control key down and left-click on the display to create another control point. Now another way to do this is to select the control point and press the E key and extrude the new control point. The new control point is placed into grab mode and can be moved to a new position. I'll select the endpoint and press the E key followed by the X key and extrude a new control point along the X-axis. When Bezier curves are joined like this, or rather extruded like this, they form what is referred to as a B-spline. In this case, a uniform, non-rational B-spline. To join the endpoints of a B-spline, go to the Object Data Properties panel for the Bezier curve object, and in the Active Spline panel, checkmark the cyclic U checkbox. This closes the B-spline and creates a surface defined by the position of the control points and the curve attributes of the control point handles. The Bezier curve surface can be then shaped by adjusting the control points and their associated handles. I will tab out of Edit mode and rotate my view. Notice that the Bezier curve surface is a flat, two-dimensional shape. I'll tab back into Edit mode. The surface of a closed Bezier curve spline is actually the product of 2 settings. Firstly, it is a closed spline, which we effected by clicking on the cyclic U checkbox in the Active Spline panel. Secondly, the Bezier curve object shape is set to 2D in the Shape panel. You may remember that we changed this from 3D to 2D earlier in this video tutorial. All Bezier curve surfaces are the product of a closed 2D Bezier spline. If I switch the shape setting to 3D, the surface no longer renders. I'll go back to top view. Now that the spline is a 3D shape, even though all of the control points currently fall on the 2D XY plane, Blender displays the arrow markings on each curve segment. These arrows point to the front end of the curve. In the case of a closed spline, they point to the forward clockwise direction. Although the Bezier curve is a continuous mathematical object, it is nevertheless represented to Blender's render engine as a discrete set of small segments. This is done by setting the resolution property, which defines the number of points that are computed between each control point. The default resolution is 12. We can determine this by the resolution setting in the Shape panel of the curve's Object Data Properties. Increasing the resolution of the curve will increase the resolution of the rendering of the curve. It is also possible, as we'll see later, to convert the curve object to a mesh object. Increasing the resolution of the curve object will increase the polygonal definition of the mesh object. I'll tab out of Edit mode and go back to top view, and I'll add a Bezier circle object to the scene. I'll then tab into Edit mode. A Bezier circle is simply a closed 3D Bezier spline with 4 control points set to auto mode, forming a circular curve. With all the control points selected, I'll press the V key, which places the handles into vector mode, making each curve segment a straight line. I will change the Bezier circle object from a 3D shape to a 2D shape. Now, since the Bezier circle object is a closed spline and is now a 2D shape, a surface is added to the object. I'll switch all of the handles back to auto by pressing Shift-H. I'll open up the 3D Viewports Tools panel on the left side of the 3D editor by pressing the T key. Now here there's a number of very useful tools to edit a Bezier curved object. I'll select the bottom control point and click on the Vector Handle button. The handles are now in vector mode. I'll move this control point down a bit. I'll select the left and right control points and then press my S key and scale them up a bit. I'll select the top 3 control points and click on the Subdivide button in the Tools panel and subdivide these segments. I'll select the top control point, change the handle to vector, and move it down a bit. I'll go to the Active Spline panel and uncheck the Cyclic U checkbox. This breaks the closed spline at wherever the original front and back ends met. As this is no longer a closed spline, it has no surface. I will recheck the Cyclic U checkbox, which will restore the closed spline and its surface. When compared to meshes, Bezier curves and Bezier curved surfaces have both advantages and disadvantages. Because the curves are defined by less data, they produce nice results using less memory while modeling. However, at rendering time, the memory demands are greatly increased. Now, some modeling techniques, such as extruding a profile along a path, are only possible with curve objects. But the very fine control available on a per-vertex basis on a mesh, as well as the wide toolset of mesh modifiers, are not available to curve objects. In subsequent video tutorials, we'll examine more of the Bezier curve and Bezier surface properties and how curves can be used in modeling complex objects.